Okay, welcome back. So in the last lecture, we talked about using raster IO to open raster dataset, manipulate raster dataset, and also save dataset as GeoTIFF. And as you probably noticed, it's not very easy actually to use raster IO because you have to handle those low-level things by yourself. You have to deal with like how big is your image, what's the width and height, how many bands, and also the most annoying one is the GIS transform because you have to calculate that one yourself. And so for today, I want to introduce another package also doing raster analysis, and it's called Xarray. So this one is not really used for doing handling GeoTIFF yet. So in the next lecture, we're going to cover the other one called raster IO Xarray. So that one extends raster IO, makes it easier to use. And but before we get into that one, we need to cover Xarray. So Xarray is a Python package that's for working with multi-dimensional label dataset. What does that mean for multi-dimensional label dataset? We'll get into the examples later, but Xarray built on top of NumPy array. Okay, so we have covered NumPy array in the previous lecture, and so by now you should understand that NumPy array basically is just think about this matrix. But previously, when we're doing the matrix indexing, it's also not very intuitive because you have to remember what's the row and the column number, the start and the end. So you have to figure out these numbers, what's the index, right? 1, 2, 3, 4, especially if you're dealing with multi-dimensional matrix. It's even more challenging because you have so many columns and it's very arbitrary. Xarray makes it much easier to use because you don't need to worry about the dimension, the absolute dimension. You just need to remember what, for example, what's the label, and you can think about, for example, what the latitude and the longitude range, and then you can just specify. Then you'll be able to do that. When we get into the examples, we have much better understanding about what is that. So for today, we're going to cover what is Xarray, and there are two data structures in Xarray that you need to understand. One is called data array. The other one is called dataset. And so these two are basically the building blocks of Xarray. And what we are dealing with mostly, we're dealing with an array, or we can dealing with the dataset. So here is the diagram from the Xarray website. So think about this one here. We have the so-called the dataset. You can think about dataset just like a GeoTIFF that we've been dealing with. For example, a landscape imagery that we work with in the raster IO lecture, right? A landscape imagery has 7 spectral bands and have width and has height, loss XP, and also have a lot of properties. So you can think about this is kind of you can read it as an Xarray. Again, we covered it in the next lecture, but here I just want to let you know an Xarray dataset is a collection of data arrays. So data array looks like this. If you're dealing with remote sensing, for example, we have data about temperature, about precipitation, about anything, about soil moisture. So there are a bunch of different properties that we monitor, and then we collect it, and then we transform into some kind of a raster imagery. So in terms of temperature, think about like every day or every hour, we have one temperature imagery, right? Different time series. And then when you put them all together, it becomes a kind of a data cube. So think about every location, leg long is the coordinates, and also you have the dimension, the time dimension. And then we also have the so-called variable. Variable basically means what is that data about. So, and the coordinates is where you can do the indexing. So the coordinates is the one that's makes it really easy to use, the so-called dimension. So in here, we have the latitude, we have the longitude, and we also have the time, right? So for example, the temperature here, right? Today, tomorrow, the day after tomorrow, or by hour, by minute, whatever the time period that you have. So let me give you a real world example. So let's say I give you an imagery covering the entire globe. of temperature. Okay, and they say it's a 360 columns by 180 rows, for example. And I ask you, just give an imagery, for example, for yesterday, just one imagery, and I ask you the question, what's the temperature of Knoxville? So how are you going to do that? So basically, you need to load the imagery onto the map, right? And you need to figure out where is Knoxville located. And you need to get basically the leg long of the location that you have. And then you can pinpoint your mouse on the map, on the imagery to get the pixel values. But the problem is that if I open it using, for example, NumPy array, it's just a matrix. So you have 360 columns and 180 rows. You need to figure out the row and column number of the location you're interested in, right? Let's say Knoxville might be 125 columns and maybe 90 rows or whatever. It's arbitrary. So how do you figure out the arbitrary number? You need to convert from latitude longitude back to that number, or you need to open it on the map and then you just inspect manually. It's not very convenient. But in terms of Xarray, you don't have to worry about the row and column number. You can just say, okay, data array dot select latitude equal to 39 point something, longitude equal to negative 120, for example. If you know the latitude and longitude, you don't need to convert back to the absolute column and row number. So this is the beauty about the Xarray, because you have the dimension, so-called latitude and longitude. So if you know the location, then you can just select. You can also select by time, so you can select whatever coordinates that we have. So this is so-called a multi-dimensional label data set. So multi-dimensional means, think about X, Y, Z, right? So everything on the Earth surface, you have the latitude and longitude. You also have the elevation. Make sense? So we can just select, for example, okay, if you want to figure out any location, you can just give a latitude and longitude and also give the elevation. Then you can pinpoint that certain location. You don't need to worry about the absolute. So if I give you a data cube, you don't need to worry about the absolute number, row and column, and also the G value. You can just specify the label. So the label in this case here, multi-dimensional, right? 1 dimension, 2 dimensions, 3 dimensions. So X, Y, Z, you have 3 dimensions. And the label means you have the latitude, you have the longitude, you have the elevation, or you can have the temperature, you can have anything else. So that latitude, longitude, and also the temperature is the label. Okay, so this is what I call multi-dimensional label data set. And it makes it easy for you to do a subset or do all kind of calculation. Make sense? And so this is kind of diagram. We're going to deal with the data set later. So in order to use Xarray, you need to install this one Xarray. So we have installed the environment. So if you run it on Google Colab, then I think Google Colab might have already have this pre-installed. I forgot that. And there's also another package called Pooch. So this is the one that we use to download a sample data set from Xarray. I don't know why they choose the name, but whatever they use, we're going to use the same example. So let me switch back to VS Code, and then we can get started how to use this one. All right, so let's import the library. It should be pretty easy and straightforward. As I mentioned, Xarray data structure has 2 primary data types, data set and data array. So let's look at the data set first. And oh, by the way, so when you import Xarray, this is the convention. Just like import NumPy as NP, usually we just import Xarray as XR. So this is the convention that when we import the libraries. And once you have the XR, then you can use this one, tutorial.openDataset. So if you want to learn more, you can just type XR dot, right? And then it's going to show you a bunch of lists, tutorial dot. And so this one has load dataset, open dataset. They're the same, so you can just use the open dataset function. Right? And then you have parentheses. So here it should show you the help documentation, right? What's the name of the dataset you're trying to open, and what's the case directory, where you want to keep the case or not. So what this one is doing, you just provide this one air temperature. So this is basically a built-in sample dataset. I provide a link in here. If you click the link, it will take you to the website. So this one shows you some of the sample data set comes with Xarray. Of course, you need to download it, but we are using this air temperature. There are a couple more data sets in here. For example, later in the exercise, I will ask you to maybe to deal with, for example, this data set. So right now, we are basically opening this the temperature data set, and you can just run it. And let's take a look. So by the way, because this is the Xarray variable, it's very much similar to NumPy array. You probably would just print out the variable rather than use this one. You don't want to use this. You will see it's very different. So if you use the print function, the print out the data Xarray data set will look like this. So it's not very user friendly. So usually you just print out the variable. That's a better one. So in that way, you can have this rich representation. So you can click the buttons to show the data, something like that. So xarray.tutorial.open dataset. If it is not from the tutorial, you can just xarray.open dataset, and then you can do the same thing. So let me show you here. Right now, if you use the open dataset, the outcome, the return data type will be dataset. So basically, provide me something, I will open the dataset, and we'll return this one as the dataset. And later we get into the data array. Right now, this is basically the entire dataset. Also, keep in mind, when you use Xarray to read something, it doesn't load all the stuff into the memory. It actually just pointing to the dataset, read some metadata. It's not holding. If Xarray can open a dataset with many gigabytes or even terabyte, it doesn't load it into the memory. It's only request on demand. So only when you need to do the computation, you're going to get it. So right now, this is how we open this dataset in here. And so it's going to show you the data type, the dimensions. Okay, so the dimension basically, think about, this is an imagery of air temperature, latitude and longitude. So basically, there are 25 rows, 53 columns, and then 2,922 bands, because it's air temperature. So this one, you can take a look at the dimension in here. 2013, January 1st, and then T, 00, this is hour, minutes, seconds, right? So this is the same day, this is 6. So basically every 6 hours, it has one temperature imagery. Every 6 hours, so it's covering almost 2 years of data set, air temperature. And it has like this small tiny area. So you can think about it as like a data cube, very tiny one, and has over almost 3,000 slices. So think about if this is the remote sensing imagery, it can also be represented in this way. Also, you can see the latitude and the longitude here. If you click this one, you're going to show you an array. So the latitude, this will be 75 degree, 72.5 degree, and 70. So basically, it's decreasing the latitude from the high latitude to low latitude. And also the longitude here, 200, 202, something like that. So this is kind of like 2.5 degree, 2.5 degree raster imagery. And you have time dimension. So we have the coordinate, basically means the dimension means how many dimensions you have, and the coordinates is within each dimension what's the array of that dimension. Also, you have the indices. This is important. If you don't have the indices, you cannot do the slicing. So with the indices, right now we can select the dataset very easily. And here are some of the attributes. Okay, so references, model, description, something like that. So you think about this is the metadata that we get from the Xarray, right? And so this one under the hood is an NextCDF dataset. If you want to learn more, so NextCDF is a very commonly used data format especially in climate science or oceanography. And in geography, we also use that remote sensing, but usually we use GeoTIFF. But NextCDF certainly is a very common data format, especially if you're trying to download some data from NASA. A lot of NASA data are stored as NextCDF format. So now if you know Xarray, you can use it to read any NextCDF dataset that you downloaded from NASA. And if you're wondering, where is this dataset being downloaded to? Because we're just providing the name and then it's like open just like magic. But under the hood, it's being downloaded to your computer. So if you look at this one in here, depending on operating system, it's being downloaded. So right now I'm on Linux computer, so I can show you where is the data set that we just downloaded it. So I'm going to go to my home directory, and it's under the cache. Then there should be one called Xarray. Let me see here, Xarray tutorial dataset. So look at this one. Blah blah something dot. Let me zoom in a little bit here. Oh, the text doesn't zoom in. It doesn't matter. Anyway, so you can see the file extension something.nc. On a Windows computer, it's a different file path, but you should be able to find it on a local computer. This is a hidden file path, so if it is not showing up, you might need to unhide it. And let me show you the other way of opening this dataset. So for example, you might have downloaded a dataset from somewhere, from the internet, and it's a .xcdf file. So you can just put it under within your computer. So for example, I can copy this one, and I'm going to go to the Geospatial directory in here. I can create a new directory called data. And I have this .xcdf data downloaded from somewhere. And then I can rename it, okay? Air temperature.nc. So imagine this is some data set you downloaded from somewhere. And you can do the same thing just like what we are doing here. Let me create a new code block, okay? And I can just do ds equal to xr.open dataset, okay? Same thing, parentheses. Okay, pay attention. I'm showing you how to open a dataset locally. So if you have any files that you downloaded from somewhere, you want to open it, then I can just provide, for example, the file path data, and then air temperature.nc ds. Run it. Do you see the same result? Right. So it's also returning a dataset compared to the one that we use above, Xarray xr.tutorial.open dataset. So that one is a sample dataset from the internet. So what it's doing is going to the website to download the dataset and then put it in a temporary directory and then open it. This one here is open any dataset you like, but it's the same temporary same dataset because I copied the one from the temporary directory to my computer, and now we have access to the same dataset. So this one, you can open a dataset also directly from an HTTP URL. It doesn't have to be a local one. So it's up to you where you want to do that. So for example, let me show you. I can do it this way, dataset. I can go to my, how about my GitHub repository? And I'm going to open a dataset under here. So kind of like the raster.io example that we talked about last time. So I can go to any website. And if you find any dataset, for example, here, I have some .xcdf sample dataset somewhere here. And I also upload this one, the air temperature here. So what I can do here, I can also copy this link address. And then I can just pass in here. It should work as well. Oops. HTTP. File not file. It should. Okay, never mind. So in the next lecture, raster.io Xarray, that one will work. So this one looks like the Xarray doesn't allow you to directly open this one from HTTP URL. Interesting. I saw it supported. Anyway, so let's open this local dataset. Then we can start working on the data array. So again, this is a dataset. Okay, a dataset can contain multiple data arrays. So think about a dataset can contain temperature, elevation, moisture, precipitation. It can contain anything. So think about, you have different images. You can combine all the images as long as they share the same coordinates, share the same dimension, because everything on Earth basically have latitude and longitude, right? And if you have the same data set covering the same area and with the same extent, but they represent different things, you can put them all in the same data array. And so this is what this one is doing here. Again, make sure you understand this data variable here. Data variable basically means the data set contains a certain type of data variable. So right now we only have one, but it doesn't have to be one. You can have a lot more variables. So This one variable name here is called air. So basically it represents air temperature. So how do we access that data array? Is through this square brackets and then just the name of that data variable. This is very much similar to the pandas, okay? Or GeoPandas, if you remember, right? We open the data table and then you get the column name. For example, DF square brackets, latitude, longitude, something like that. So this one, we are accessing the data variable. And if you run this one, okay? So right now, pay attention to the differences of this one with the one above. The one above is called Xarray dataset. Right now, this one is called Xarray data array, okay? So it's a data array, it's no longer a dataset. And you don't see the data variable attribute here anymore because we have extract the data array from the dataset. It's no longer Xarray dataset, it's a data array. So data set is a collection of data array, so you can have multiple things within the data set. But like I said, temperature, precipitation, anything like that. And other than that, the latitude, the longitude, the time still remain the same. It's the same as the previous one. Make sense? But the attribute is different. So every data array can have different attribute. So look at this one. Because this is specifically for this temperature, air temperature data set. So it's not the entire data set. So, but the indexing, so basically the coordinates, the index, and are the same. The attributes can be different. Also, the shape is the same. So still is how many time periods? 2,920. How many latitude? How many longitude? So this is how you access the data array from the data set. The other way is using the dot notation. So dot air is the same thing, the same result. Okay. What you need to do here, if you want, you can just ds dot something, and you will open up all the things that you can do with the data array. So there are lots of functions and methods available in here. Again, whatever you need to do, just air, and that variable need to exist. If it doesn't exist, then you're going to run into error. For example, it doesn't exist. Okay. So this is kind of like, you can think about, it's a pandas data frame. It's trying to access a column or something. That column name need to exist. If it doesn't, then you're not going to be able to get it. Questions? So let me go back to this example. I just want to make sure you 100% understand what I'm talking about here. So the data set is, right now we're opening a data set. It's called air temperature.nc. And when we open it up, inside there's a data array called air. Okay. Right now this is basically the same as temperature, but we don't have the precipitation, but you can have that in here if you want to. But right now, basically, you can think about, we open the data set and we end up with this data cube. So this data cube has 2,922 bands, okay? Because it's a time period. And it has latitude, it has longitude in here. So latitude, longitude, and also the time dimension. That one is so-called the coordinates or the dimension. And the coordinates basically means you have latitude, longitude. So every pixel location has a latitude, longitude, and also the time dimension. So the x, y, t. And you have the data variable. Right now we only have one, but we can create more data variables, add more data variable if needed. And with that, now we can start accessing the data. So again, so ds air, and the same thing here. So the temperature right now, this one is a data array. Once we have the data array, then we can get more information. So this is, again, the temperature right now is a data array. So what we're talking about here, right now we are dealing with this one. Okay, this data cube here, 2,922 bands. How many rows? You can do it like this. Again, temperature, dot shape. So this is how many bands, this is how many rows, this is how many columns. Okay, so basically the data cube, you can just use this one dot values to get all the value as a numpy array. So then it goes back to what we covered. The NumPy array, this is like a 3-dimensional array. So you're going to see all the numbers, 200 and something. So basically this is the temperature, air temperature of the location. So if you want, you can also type the shape. It should be the same, right? So the same shape, the same size. Doc values, get everything out of that. You can also doc themes. Themes means the dimension. What's the dimension, okay? Again, we are talking about this data cube in here. What dimension do this data cube have, right? You have the latitude, you have the longitude, and you have the time, maybe here, latitude, longitude. So be like this. This is latitude. In here, this is latitude. This one is longitude. And this one is the time dimension, okay? So basically you have 3-dimensional. So themes means what kind of dimension do you have? X, Y, Z. So X, Y, this one is X, Y, T, right? Latitude, longitude, and the time. You can also have coordinates. Coordinate basically means what's the value of each dimension. So each dimension, for example, latitude. How many latitude do you have? What are the number of the latitudes? Similar longitude. And the time dimension, for example, 2013, January 1st, right? Hour 0, hours 6, 12, 18, 24, something like that. So you have this kind of 3-dimensional. Also, you can access the attribute ATTRS. So this one is what is showing up in here. This one. So you can get access to all the attributes. You can also assign a new attribute if you want to. So let me show you this one. Because this attribute is a dictionary, so if you want to save some additional information into the data, you can do that. So I can maybe square brackets, and then I can say creator, for example, and you can equal to maybe let's say Noah, okay? So basically modify the attribute as you go and run it. Run the code again. So now if you just type temperature ATTRS, you see, I added another one. And this one is basically exchange back to the data array. So right now, if I just print out this data array, temperature data array, and execute it. So now you see we have attribute. We have 12 attributes. And this is the one that I just added. So some of the attribute later, you can add the attributes to the data array. And then later on, when we're doing the plotting, doing some analysis, you can get the information programmatically. So this is how you can modify the data set. Questions? Okay. And these are all simple and easy. So basically, we are downloading some data set. We open the data set. We get the data set. And then we get the data array. Okay. So data array is basically just whatever data. How many depends on how many data available in there. Right now we are just working on the temperature. Next, let's start doing something really cool stuff, and to see how easy it is to do some aggregation. So again, this temperature data array. Let me show you one more time here. Right. So this one has 2,922 bands, 25 latitude, and then 53 longitude. Okay, so 25 and 53 is not a specific pixel, okay? It's how many rows, how many columns, okay? In terms of latitude. And look at this one here. This is the data cube, right? This is the latitude. This dimension is longitude. This is the time. So imagine, right? As I mentioned at the beginning, I give you some temperature every 6 hours. And I'm asking you, for this entire time period, calculate the mean temperature. Can you do that? For example, like how do NOAA or NASA, they figure out this year, this last July, was the hottest month on record? Or what's the average temperature last year? What's the average precipitation last year? Because you're going to have a lot of time periods of the images. And like I said, this is just like data cube. So how do you calculate the mean? For example, look at this one. Look at this this corner here, this location, right? This latitude, this longitude. So you have 2,922 bands. you need to aggregate all of them together to calculate the mean, right? And so once you calculate mean, we end up basically we reduce the dimension just to just one imagery. So to calculate the mean temperature. In Xarray, it's very simple. Look at how easy it is. Temperature dot mean, and then you can specify the dimension, which dimension you want to calculate the mean. So this one here, because we have this time dimension, right? From January 1st to December 31st, 2014. So basically 2 years of data every 6 hours. So what we are doing here is just one simple line. What we are doing here is basically, okay, calculate the mean temperature by time for every location, for every pixel, right? So we have 25 latitude, 53 longitude. So every pixel is going to get the value for that pixel for across time, and then just calculate the mean. So for example, if I ask you, okay, calculate the mean temperature for Knoxville for last year, and I give you the imagery every day, right? So you only have 365 images. And for that location, it doesn't have to be Knoxville. It can be for the entire globe. It can be the entire US. So all we need is just take this Xarray data array, just apply the mean function, and then it tells you you need to calculate the time by time. So in that way, you preserve the location information. If you don't do that, again, so this is the result. You take a look here. We have the latitude still 25 pixels, and then 53 pixels for the longitude, because we specify the time dimension. But you can also do it like this way. If you don't specify the dimension, you're going to aggregate all of them. So pay attention to what this one result going to get. See? We only end up with one number. What does this mean? So it's basically taking all the number, put them all together, and just calculate the maximum. So this will be, use case will be like this. What's the maximum temperature last year for the entire globe? If I give you the global imagery every day, and this one is basically what's the maximum temperature. It doesn't matter the location, you just put them all together, and then put it all as a number, and then you calculate just one. So this one is not calculate the mean by time. Is the time doesn't matter, the location doesn't matter. This is why here, if this is what you want, it's basically just taking the maximum temperature, and it's similar. It's the same as this one. So like I said earlier, temperature dot values, right? If you're using Xarray, you are getting all these numbers, and you can apply dot max. You should be getting the same result. So take a look, 281. Oh no. Values dot max. What was doing? Oh, the mean. Not the max. Mean. Yeah. So they're the same, right? 218.3, 281, 281.255. So it's the same number. So you can, but again, make sure that if you want to calculate by dimension by time, then you need to specify the time. You can also calculate by latitude or longitude, whichever way you want. And after that, you can just do some subtraction. So this is similar to the NumPy array. It's going to do the broadcasting. So what this one is doing is taking the temperature minus the mean temperature, because the mean temperature only has one imagery, right? And temperature, this one has 2,920 bands. It's going to, every band is going to minus the mean temperature. So in that way, you get, the result will be the same number of bands, 20 bands, and minus temperature. So in this way, you get the so-called anomaly. Or normally means like how far are you away from the mean, right? And this is also useful. You see, just 2 lines of code, you can do a lot of things. If you're using NumPy array, you have to deal with the numbers, and it's kind of not very intuitive. So this is how you can do some simple mathematical operations. And similar to raster IO or NumPy array, we can use matplotlib to do some visualization. So it's much better if you can see the imagery easily. Xarray has this called plot function. So whatever Xarray data array that you get, you can just dot plot. It will plot the data set. So look at this one. Super nice. So now you see we have this data array, and then we plot using the plot function, using matplotlib. And so what we are doing here, like I said, this is the mean temperature. So we are taking the entire, those 2 years of basically the mean air temperature from 2013 January 1st to December 31st, 2014. So if 2 years of temperature data, you calculate the mean temperature for those 2 years. And now we are plotting this mean temperature using Xarray, just using the simple dot plot function. And we also have this all nicely, X label, Y label, and also the label for the legend. And I want to let you know, the label come from here. The long name, yeah, 4x daily, something like that in here. So the long name is being used in here, in this legend variable. So you certainly, if you need to change it, you need to change the long name if you want. So let me do it one more time here, just to show you. So I can do mean temperature, for example. Again, this is the data array. So right now we're trying to modify this data array so that we can do some plotting. So what you can do here is to dot attrs again, and you can change the long name. Long name underscore equal to, for example, mean air temperature or something like that. You can change it to whatever you want. And now if you do the plotting, you should change it. See? Mean temperature. So you can update the legend. So the legend comes from the attribute. So that's why I mentioned earlier, the attribute sometimes can be important because some of the things is automatically use the things from the plot from the attribute. And we also have this one here, degree K is actually this one, the unit. Okay, so you can also change the unit, and then you update the legend. It's whatever you want. So this is the default one, and you can also do some customization. For example, I can update to it something like this. So you can change the color map, the C map. You can also change the figure size, change the label, X label, Y label, also the title. So what we are doing here, we change this one, the X label, the Y label, the title, and also the legend, right? And looks a little bit better, right? Compared to the one above. This is the default one. And the latitude here, it says degree east, degree north, blah, blah. Sometimes if you don't want it, you can change it. So all you need to do is just this plt dot title, X label, Y label, the color map. So you can change this one to whatever you want. For example, I can change it to something else. For example, cool warm. Okay, you can change it, and the legend also be changed. I can change it to blues. It's very flexible. If the color doesn't exist, it's going to show an errors. Okay, so this is why you see here the blue need to be blah 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 la 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 la. It's a long list in here. So you can, for example, orange, red, green, blah blah. Here. All right. So up to you what you want to do. I think I've showed this one before. For example, matplotlib color map. Or color map. Okay. So you can see something here. Choosing the color map. Sometimes if you're working on the map, you might want to choose a color, whatever color you like. So look at this number in here. By default, it's using this one. VIRIDIS is this one. So this is why when you don't specify a color map, it's going to plot using that one. But you're welcome to go through this one here and then choose just figure out the name, whatever name you like, and then you can just pass in the name back to the code. For example, I can change it to HSV. So let's try it out. HSV, run it. Okay. So it's super nice. You can kind of like in desktop GIS, you try to change the symbology easily. Questions? So this is doing the plotting for any band, or you can do the aggregation, calculate the mean. So the next one here, you can also plot a plot for a particular location. So think about this one. This is where Xarray really shines. We'll talk about more later, but right now I will give you an example. As I mentioned earlier at the beginning, the real world scenario will be, I give you a global imagery of temperature, and I ask you to plot maybe a temperature for those last 2 years, and I ask you to extract the temperature time series for Tennessee, for example, or for Knoxville, right? So you need to know the latitude and also the longitude. So once you know the latitude and longitude, look at this one here, cell. The temperature.sel. SEL means select. And select, you can specify latitude equal to 40, longitude equals to 260. So in that way, you don't need to remember the absolute number, because the latitude and longitude for certain location is always going to be fixed, right? But the imagery that you are working on, the size might be different, right? You can get an imagery covering the US, or you can get an imagery covering the entire globe. And the row and the column number for that certain location is always going to change. And if you don't know the absolute number, it's using Xarray, you cannot really pinpoint that location. But for Xarray, it doesn't matter, because it's a label data set, and we can use latitude, longitude, whatever coordinate you want to extract. So what we're doing here is to select, select the time series for this location. So let me copy this line in here. And we are picking this location, and for this time period, you're going to get, maybe, for example here, 2,922 points, right? So what we're doing here, we have this time series, we pick this location, it's going to extract the entire time series for this one. And then it becomes another data array. So right now, this data array is just one dimension, okay? Along a line. And then you can apply this function, dot plot. Then you will plot something like this. Of course, this is like very dense time series, because every 6 hours you get 1 point. It's 2 years, so it's like a lot of points. And this might be a little bit difficult to see, but you can maybe increase the size. So you can say figure, and figure size equal to maybe 20. So in that way, you can expand this one a little bit to make it larger. So this should make it easier for you to see the entire time series in here, right? So it still is very, very dense, but you can do some sampling. We can also do some aggregation. I will show you some examples later. Questions? So you can do plotting, basically doing for one imagery, or you can pick a location and then you can select them. One thing I want you to pay attention to is here, when you are selecting this latitude, longitude, it needs to exist in the original data set. Otherwise, you want to run into error. So for example here, again, pay attention, you will most likely run into this error later. So I can do, for example, longitude equal to 261. And let's see if it works or not. Oop, it doesn't work. So what does that mean? Not all values found in longitude. Try setting the measure keywords, measure equal to nearest. So why this is happening? And let me show you temperature. Again, earlier we talked about the coordinates, right? So the longitude equals to 261. So if you click this one, again, these are all the coordinates, all the longitude available for this example. So where is 260? 260 is here. But there is no 261. Yes? There's no 261. So when it's trying to select, if there's no absolute 261 here, it doesn't know which one to use. So this is why in the documentation here, it says, for example, set the measure equal to nearest. So what you need to do here is to pass in this one in the nearest. So what does this really mean is, okay, I'm trying to select a longitude equal to 261, but it doesn't exist. You're going to find the closest one. So the closest one will be this 2 here, right? Which one is the closest to 261? 260. So what does this mean? It's going to select 260, okay? If I, for example, if I use 262, which one is good, closer? 260 to 45. So if I execute this one, I want to show you. Run this one and take a look. Latitude 40, longitude equal to 261, okay? I'm 100% sure you're going to run into these errors. So when you're doing the selection, Xarray doesn't automatically, because there might be some unintended consequences. So you need to make sure that what you are doing, you know what you're doing. So right now you are, okay, I want the nearest one. Or you can do the average, or you can do all kinds of things. So for this one, we just want the nearest one. So that's why it's picking up this 265. And after that, you can, for example, I can do 262. The line should be very much similar. Again, here, it doesn't work. So you need to say measure equal to nearest. And then you can do the plotting. So this is how you can get the time series out of that. All right, so this is how you can do some simple plotting. So next, I'm going to show, like earlier, the DS is the data set, right? So let me print out again. The data set is when we open, use the Xarray open data set. So we end up with an Xarray data set. And the original one, so the data variable is this one, right? So right now we only have one data variable called air, and the time and blah, blah. And this is how you can access the data set, right? Either by dot notation or by using square brackets. And again, we can also do the mean and then just calculate the mean across time. Then you are aggregating all the data sets. So we are reducing the data set from 2,922 bands to just one band. So you calculate the mean of every pixel across time. So you can specify the dimension. You can also do it like this. Maybe calculate by latitude, you see? And you can calculate by longitude. To see the result, the outcome in here. So if sometimes you're trying to calculate the differences, for example, by latitude, you're trying to see, for example, the temperature changes by latitude, then you have to do the mean by the latitude, and then you will be able to see the differences. So this is how you can open the data set and then do some manipulation, calculate the result, and also doing some plotting. In the next section, I'm going to do a comparison between Xarray and NumPy array. So you understand why do we want to use NumPy array. And so all the data set, everything, you can either use the doc values or you can use the doc data to access the NumPy array underlying the data array. So again, one more time, it's kind of confusing for beginners because there are different ways you can access the data. Again, the DS, this one is the data set, right? And the data set has this data variable. So we can use the doc air to access the data array. And then because this data array is a data array, under the hood is NumPy array. So this is why you can shape this one. You can use doc values. Okay, this is one way to get the NumPy array. Or you can use the doc data. You see, these two variables are the same. So doc values or doc data is to get the NumPy array under the Xarray. So because the Xarray extends NumPy array and adds the dimension, multi-label things to it. So if you need to access the NumPy array, you can do it like this way. As I mentioned earlier, this is a multi-dimensional array. You can use the doc shape, right? The same shape that we used earlier. So if you need to maybe just plot the imagery for the first band, then you usually need to do the indexing, right? So this one here, because it's a temperature array, multi-dimensional, and what we're doing here is, okay, I want to plot the imagery for the first band. For the first time series, okay? So we have 2,922 bands. I want to plot the first band. So this is how you can do the selection. Temperature 0, and then this is rows, basically the latitude. This is columns, right? So look at this one. Where is this area? Can you see that? Can you see kind of the rough shape of this imagery? Where does it cover? Probably can guess it. Do you see some North America? It's like the US. You can see kind of like this. Yeah, the shape like the US. So this is, for example, right now, this is a NumPy array, okay? We are accessing the NumPy array. So if I'm asking you, right, so this imagery, this data set has 2 years of data, okay? From 2013 January 1st to December 31st. And we are just displaying the January 1st, 2013 January 1st, the first one. So let me ask you, I want to display the imagery for January 1st, 2014. How do we do that? Using this NumPy array. So this is the first, like, again, like I'm asking you, we have 2,922 bands from 2013 January 1st, every 6 hours, right? And right now we are displaying the first one. It's easy. The index is 0. But what I'm asking is, I want the 2014 January 1st. So how are you going to do that? You're probably thinking in your mind, okay, every 6 hours, okay, index 1, index 2, index 3. Probably, I mean, because it's 2 years, probably somewhere in the middle, right? Maybe 1,495 or something like that. So you get the idea, right? It gets very challenging because you need to count the index. But if using Xarray, you don't have to. So for example, I can do it this way. Maybe this is just 1,500. I don't know. I don't know which one is actually the correct time. You should be able to plot it. But the problem is that this is an absolute number. It doesn't really give you intuition like, is it January 1st, 2014, or is it this February 1st? I don't know. It's hard to say. Or even, for example, right now this covers North America. I want you to do the indexing covering Tennessee. And the image size can change, right? Right now this covers North America. I can give you another image covering entire globe. And then it's going to be like, okay, look at this one, right? So this is how many rows, how many columns, right? This one has 25, what's the 25 latitude, maybe just print it out. Again, it's like 25 latitude, 53 longitude. So the pixel, you can look at the pixel here. So if you're trying to do that, it's going to be difficult. 25, like 25 row, pixels by row, and then 25 by column. So in here, it's tough. So I can do maybe 10, maybe to 15, okay? The other one maybe 20 to 30 or something like that. In order to do a subset. Oops. C510 much smaller, 20 than 53. Anyway, it's going to be difficult. So like I said, this is just using the plotting mesh, basically just doing the interpolation. So now let's take a look at how do we do that using Xarray. So this is where when you have the label, the so-called label is really useful, multi-dimensional label. So compared to the previous one, we're just using this absolute number. Right now we're using this iSelect. iSelect means it's the indexing. So it's very much similar to doing the Xarray. So we're selecting the first time period, and then we can do the plotting, for example, using the Xarray, X is longitude, Y is latitude. So right now, this one is very much similar to the one above. I can do 1,500. It's still doing just the indexing. But take a look at this one. Here, 1,500. Do you see the time here? Even though right now we're using the same indexing, but at least you get the time because Xarray knows the time dimension for this one. So right now, it's January like 11th. This is probably too big, okay? So probably I will do maybe 1450. I don't know. We're just trying to, okay, it's too small. Maybe a 70. All right, it's too big. Maybe 60. All right, we get it. 1460. So this is 2014, January 1st, right? So you can use the ISEL, and we don't need to get the data or the values. It's just like the data array, so we can do the selection. But even better is this one, okay? So look at this one. Compared to the ISEL basically select by indexing. This SEL is selected by the absolute coordinate. So right now, look at this one. Time equal to 2013, or we are doing the 2014, okay? 2014, January 1st, and this is by hour, by minutes, by second. Okay? So now it doesn't matter. Now you don't need to convert like, okay, what's the index for this time, right? I can do maybe 2014, July 1st. Right? See how easy it is. So you can use the time to do slicing. You don't have to use the absolute row and column number. You can just use the time to do multiple selection. So this is how you can do the selection and do the plotting, and kind of the advantage of using Xarray. Next couple example, you can also do the selection. You can select, for example, this one, 2013 May, because every couple hours it has every 5 hours you have one data set, one time period. If I just do it like this way, 2013 and then 05, that means the May. So you're going to select all the data set for the entire the month of May. And look at this one, we have 124 images for covering the same location. So basically just doing a subset of the location. You can also use the other one here called the slice. Time equal to slice. So you can have the start and also the end. So from May to July. So this you can subsetting, okay, I give you all the images covering the 2 years. And I'm just asking, okay, I only want image starting from May 2013 to July 2013. So all we need just provide is to the start and the end, and that's it. You don't need to do anything else. So it's very nice for doing subsetting of the imagery. You can also select by location. So for example, this one, okay, at the first time period, and the latitude is this one, the longitude is this one, then you will get the absolute number. So this is what I mentioned at the beginning. I give you an imagery, a bunch of images, time series, and I ask you to, okay, extract the temperature for Knoxville for a certain time. Then you'll be using this one, I select or A select. So in that way, you can use this time, the dimension, the coordinates, latitude, longitude, and the time dimension to select pixel location. So this is about the indexing. So next, I want to introduce a couple more advanced operations. So I want to see you, for example, the group by. If you remember, when we cover the pandas and also GeoPandas, right? We also have the group by, for example, group population by country, group population by certain city or region or something like that. So Xarray also has this one called group by. And look at this one, time dot season, right? So we have data for every 6 hours for 2 years. We can aggregate by season, time dot season. So it's going to aggregate them automatically, and then you can calculate the mean. So basically, you're going to get the mean temperature by season for the 2 years, and then you can just do the plotting. Look at this. How nice. So easy. So you don't need to, if you're using Xarray, using NumPy array, you have to loop through the NumPy array and then figure out, okay, is this imagery, is it the springtime? You put it into the spring, is it summer? And then you need to aggregate them, like doing multiple, like there's so many lines of code you need to write. For Xarray, one line. So group by time dot season. The time, basically we have the time dimension in here. So you're going to automatically figure out, okay, for each day, what kind of season it is. And then it's going to calculate the mean. And after that, we can just plot by season. So look at this one. Season equal to December, January, February, right? The winter season. And this will be the springtime, January. No. Oh, the June, July, August. So this one is summer. Sorry, it's kind of the order is mixed. And this one will be March, April, May, and this one will be September, October, November. So you see, we are creating a plot of 4 seasons based on 2 years of data, aggregating for the entire region, just one line of code. So think about how easy it is, just aggregating like this way. You can also do so-called weighted average. This one is a little bit more complicated. So what it's really doing, you can have this one data array, and then you have a weighted function, and you can pass every pixel by area. So for example, you can, when you're doing, for example, travel or transportation, sometimes for every pixel, for example, you're going to give you a different ratio, different weight. You can have another array to multiply every value in that array. So in that way, you basically, not every pixel have the equal weight. For example, the larger the area, you're going to have a larger weight or something like that. Then you can also create something like this. Also, you can do in the rolling operation, rolling window. So what this one is doing is that you can do the rolling average by latitude, by longitude. So it's more like in remote sensing, this is called resampling. So resampling means like, let's say you have an imagery of 100 pixel, 100 rows and 100 columns. You can do the aggregation, and then you can, for example, aggregate 10 by 10, 5 by 5. So you're going to end up with a much smaller imagery. So basically, it's like doing like resampling, smoothing the data out, or you can use to highlight some certain feature. So look at this one. Look at this one. Right now, we're doing the rolling window average by latitude and by longitude by 5 degrees. So compare this one to the original one. Let me show you here. DSA dot mean, and then dimension equal to time, and then dot plot. I'm not sure if you can see the differences. Upper left corner, some of the data are kind of empty right now because it's on the edges. So if I change this one to a much larger number, you will notice the differences. For example, 10 is aggregating, basically take all the pixels nearby and then calculate a new number. So it basically smooths things out. And compared to this one right now, you see the upper left corner is gone because those pixels is on the border. So it's no value. And that's why it looks like this. But you can see this imagery is much more smooth compared to the original one above. Okay, so let me take a look at, let's take a look at another example, right? So earlier I showed you we can do the selection, right? So select by location, by latitude, longitude, and then we can plot the original one. Then we can apply so-called rolling window average. So the blue one, it's, let me change it much bigger so you can see the differences, 20, 60, like this. So the blue one is the original data, right? We have 2,922 data points. And the orange one is the average. So what we're taking here, average time equals 20. So basically kind of like, because each time period is 6 hours. So 5 data points. So kind of like a size of 4 days average. So this is similar to, I gave you the temperature for every 6 hours. And I ask you, okay, calculate the weekly average temperature. So in that way, you need to figure out how many time periods. So this one is 20. So you're going to take, for each point, it's going to take 10 on the left, 10 on the right. So you're going to aggregate 20 points, and then you're going to give you this smooth temperature. So look at this. Right? What you need is basically just one line of code. This is how you do the rolling average. So it give you the data array, you just stop rolling, and then you can rolling by time, you can rolling by location, you can rolling by latitude, by longitude, something like that. And then you can calculate the mean. So what it's doing is calculating every point. For example, this point in here is taking 20 points surrounding this point. and then calculate the mean. And this is why it smooths out easily like this. So if you want to even smooth a lot more, so this number be larger or smaller? If you want to make it even more smooth, so either be a larger number or smaller number. Say it again. Bigger? How about 100? See? So you can extract the chain, right? You see right now it's much more obvious. So you're taking basically more values, aggregating more values. So overall, you're going to see the chain. So it looks pretty good. So sometimes if you have a lot of collecting a lot of data and you want to show the overall chain, like for example, people doing like temperature, climate, whatever, and you have a lot of like very noisy data. At the end of the day, if you need to do some aggregation to get the overall chain, you can do just a rolling average, right? And you can do it even better, even larger, for example, 150. Okay, you see? So now you see the chain. So it's less noisy, you get a lot of data, and see how powerful it is. Just one line of code. Getting the data array, do a rolling average, and then just calculate the mean, and then that's it. Lastly, let's talk about writing data. So here, we have doing this temperature average, right? So we're calculating the smooth temperature or getting the temperature. At the end, you can save it back to the computer. So let me come out this one first. So the data set is the one actually we are reading from the sample data set. You can directly DA-stock to NextDF, and then you will save a NextDF file. If you run this way, I think you will get a warning saying that, okay, saving variable with a floating point is an integer type without any field value, blah, blah, blah. So if you don't want to see this warning, you can turn on this one. So is type, because this air temperature is a floating type. If you don't specify, it might convert it to integer. So you have to explicitly saying that, okay, I want it to be floating 32 point data type. And if you run this one, it will not show the warning message. So in this way, you save the data back to the computer. And on the left side here, if you take a look, we should have this air temperature.nextdf. Where is it? What's the name? Air temperature. Okay, here, this one, right? So this is the one that we save. Again, this is the data set that you cannot just open using desktop GIS. You may be able to open it using QGIS. Let me see here. I'm not sure if ArcGIS support it. I think you need a toolbox to actually open NextDF file. It might not necessarily work directly. So let me try. Okay, so this one here actually QGIS support it, but again, if you open this one, if you zoom into here, yeah, the coordinate is messed up. So remember this, what we had in the raster IO? It has no idea about the coordinates. So it's in the middle of the ocean, 0 degree longitude, 0 degree latitude. And this is why you don't want to handle this Xarray dataset using this one, using NextDF and then opening desktop.js, because it doesn't handle the information, the coordinate information. In the next lecture, we're going to cover using raster IO, raw IO Xarray. That one you can actually save to GeoTIFF, so you can keep the georeference information. Anyway, so this is how you can save the data. So the function is called doc to CDF. And once you save the data, we can load the data again. Oops. What's going on? Air temperature.nc. It might be because I'm opening the dataset, so let me turn this one off. Okay, it's open, so kind of it's locked. So you can save the dataset and then you can open again. And this looks exactly the same like what we did earlier, right? You can save the dataset, you can copy, and you can preserve all the information, okay? So open the dataset, do some manipulation, save the result back to the computer. That's it. And then if you want to open it again, you can open it again. So this is how we can use Xarray to handle so-called multi-dimensional dataset. All right, so in the future, if you download the file and it's .nc file, now you know how to handle that, right? Just open it using Xarray, and then you can just do like select indexing, slicing, manipulation, doing calculate the mean by location, by time, something like that. And it's fun. It's very powerful. If you're trying to use desktop GIS to handle this, it's tricky. Okay, it doesn't even handle the location very well. Not to mention how to use those raster calculator to that. You always need to convert the data set back to GeoTIFF or something like that before you can handle that. And the other thing that I will not highlight in here, the NextDF data set. So when you use Xarray to open it, it doesn't open the whole data set. It's opening, just pointing to that, and then only retrieve the data on the fly. So in that way, you can open a huge data set, even it's larger than your memory. So this is the power of using the Xarray dataset. Okay, so that's all for today. And in the next lecture, I'm going to cover real Xarray. So that's one that we can use to open GeoTIFF and then open it as Xarray. And we're going to deal with all the geospatial information in the next lecture. Okay, so that's all. I will see you in the next one.